On July 1, 2025, NASA's Atlas survey flagged a new interstellar visitor, streaking toward our solar system at over 130,000 km. Within hours, data analysts noticed something terrifying. 3I Atlas deviates from every known comet playbook. Not only do its trajectory and velocity refuse to align with standard comet models, but even experienced scientists at MIT are raising red flags, warning that NASA's own evidence suggests this object can't be a comet at all. If true, what did we really just discover crossing into our cosmic backyard? And why can't anyone explain how it moves? The first sign that something extraordinary had entered our solar system came not from a single observatory, but from a network of telescopes working in concert. Just after midnight, Coordinated Universal Time, the Atlas survey's automated system triggered an alert for a fast-moving faint object in the constellation Pegasus. Atlas had done its job. It caught a point of light shifting position faster than any known comet or asteroid in recent records. Within minutes, the data was relayed to the Minor Planet Center in Cambridge, Massachusetts. By sunrise, a formal International Astronomical Union circular had gone out to the world's astronomers, stamped with a new designation, 3I Atlas. Don't forget to subscribe if you're fascinated by these cosmic mysteries. There's much more to uncover. The 3I stood for Third Interstellar, only the third time in history that a visitor from beyond our solar system had been confirmed. What set this discovery apart wasn't just the object's speed over 130,000 miles per hour, making it the fastest inbound traveler ever logged. It was the chain reaction that followed. Survey astronomers at observatories from Hawaii to Chile scrambled to confirm the find. Data poured in. This object was not following the rules. Its path through the solar system was hyperbolic, meaning it wasn't bound to the sun at all. It would swing through, then vanish back into the void. Early calculations showed it would miss Earth by a wide margin, but that did little to calm nerves. In the hours that followed, astronomers noticed more oddities. The brightness didn't fit the standard models for a comet at this distance from the sun. The spectral readings, essentially the object's chemical fingerprint, hinted at comet-like material, but with strange gaps and unexpected ratios. Normally, the process is straightforward. Spot an object, plot its orbit, classify it, move on. But this time, the numbers refused to settle down. The urgency was real. Within 12 hours of the first alert, teams at NASA, the European Space Agency, and major universities were coordinating follow-up observations. Astronomers who had spent careers waiting for a moment like this found themselves in the middle of an international scramble. The last time anything remotely similar happened was with Oumuamua in 2017. But even then, the initial discovery hadn't moved this fast. The sense of rarity was unmistakable. A cosmic lottery ticket had just dropped into the inboxes of the world's top planetary scientists. By the end of the day, the question wasn't just what is it, but how is this even possible? The chain of detection, confirmation, and instant debate set off a wave of excitement and anxiety. For many, it was the most alarming astronomical discovery in years, not because it threatened Earth, but because it threatened what we thought we knew about the solar system's boundaries. Scientists everywhere were left asking, if 3I Atlas doesn't play by the rules, what else is out there waiting to be found? Orbit calculations for interstellar objects are supposed to be straightforward. At least that's what the textbooks say. Plug in the positions, run the models, and the path should line up within a tiny margin of error. For 3I Atlas, those margins started to look uncomfortably wide. Early fit graphs plotted by data analysts at the Minor Planet Center showed residuals, those little differences between the object's predicted and observed positions that just wouldn't settle down. Normally, these residuals fall well within the error bars, especially once more data is collected. But for this object, the scatter stayed stubbornly high. In practical terms, that means 3I Atlas wasn't exactly where the model said it should be. The numbers didn't just drift. They bounced, sometimes exceeding what the best orbital fits could explain. On a residual chart, you'd see a series of points that should cluster tightly along a line. Instead, with 3I Atlas, they wandered as if nudged by something unseen. For dynamicists and orbit fitters, that's the kind of pattern that raises alarms. It suggests either the models are missing something, or the object itself is behaving in a way that defies expectations. Now it's important to understand what these residuals actually mean. Every observation comes with a bit of uncertainty, atmospheric distortion, instrument calibration, even the motion of the observatory itself. But when you account for all those sources of error, and the deviations still don't shrink, you have to start asking harder questions. Is there a force at play that's not in the equations? Is the object venting gas in unpredictable jets? Or is something else driving the motion? The data teams at NASA and JPL are used to dealing with messy numbers, but even they started to notice that the residuals for 3I Atlas were persistent. In internal discussions, analysts compared these charts to the early days of Oumuamua, a different interstellar visitor, but with its own set of orbital puzzles. The difference here is that 3I Atlas shows some comet-like activity, yet the fit to a standard cometary orbit just doesn't close the gap. For scientists who spend their lives tracking the subtle dance of celestial mechanics, this kind of anomaly isn't just a curiosity. It's a warning sign. The numbers are telling a story that doesn't have a tidy ending. And while most of the world moves on after a discovery announcement, the experts keep staring at those residual plots, wondering what they're missing. Sometimes a single stubborn data point can change everything. What's left is a sense of unease. If the residuals continue to exceed the expected error bars, it could mean that 3I Atlas isn't just another comet passing through. It could mean the models themselves need to be rewritten. And that's the kind of problem that keeps orbit fitters up at night. In astronomy, names aren't handed out lightly. The designation 3I Atlas carries a weight that's hard to overstate. That 3I, third interstellar, puts this object in a club so exclusive, most astronomers never expected to see even one member in their lifetime. Before 2017, interstellar visitors were the stuff of theory and science fiction. Then Oumuamua arrived, followed by Borisov in 2019. Now, just a few years later, another one has slipped into our neighborhood. The rules for these names are set by the International Astronomical Union, the gatekeepers of cosmic bookkeeping. The I marks it as interstellar, meaning its orbit isn't closed. It's not bound to our sun and it's just passing through. The number signals its place in the sequence. First, second, now third. And then there's the survey's name, Atlas, the network of telescopes in Hawaii that caught this fleeting traveler. Each part of the name is a fingerprint, a record of how rare and historic these discoveries really are. Think about what that means. For centuries, comets and asteroids have been catalogued by the thousands, each one a repeat visitor, circling the sun in endless loops. But 3I Atlas is different. Its path is a one-way ticket, hyperbolic, unbound, destined to disappear back into interstellar space. Astronomers can plot its course with mathematics, but its origin is a mystery. It could have been wandering the galaxy for millions, even billions of years before a chance encounter with our solar system. Interstellar objects like this are cosmic messages in a bottle. They carry clues about other star systems, places we may never visit, but can study through these rare emissaries. The fact that we've now spotted 3 in less than a decade is both exhilarating and unsettling. Are these visitors more common than we thought, or are we just getting better at finding them? Either way, every new detection rewrites the odds and pushes the boundaries of what astronomers expect to see. With each new interstellar visitor, the scientific community is reminded just how porous the edge of our solar system really is. The naming of 3I Atlas isn't just a label. It's a declaration that something extraordinary has happened. And with that, the race begins to understand what secrets this cosmic outsider might reveal. Tracking the motion of 3I Atlas begins with numbers, precise, unyielding, and constantly updated. At the heart of this process is the orbit solver, a mathematical tool that ingests every new observation and recalculates the object's path through space. Each position, whether captured by telescopes in Hawaii, Chile, or satellites, enters a global database before being fed into the models at NASA's Jet Propulsion Laboratory.